All right, welcome to the session, Making Your WAN PQC Safe. Let me start with one thing you all saw before, you all know. All of you. And this is basically the session abstract, right? This is the only piece of information you saw, and that's why you came. And thank you so much for coming. Thanks for your time. I really appreciate the next 60 minutes spent with me on that very important topic. I just want to highlight 2 points. That session about your wide area network. So we will be focusing on the WAN. And the second point is we will be going layer by layer, control plane, data plane, hardware, and migration. So that's exactly the session abstract, that's a framework. And this is how I built the agenda. So I will start with brief introduction just to make sure that we are talking about the same definitions, we understand the topics. And then we will deep dive into control plane. And we will spend a lot of time on the control plane. Moving then to the data plane, followed by hardware and software. And by software, I mean software solutions like Cisco SD-WAN, DMVPN, etc. And then the main, I think, most challenging point for the customer, on the customer side, is the migration. Because you will see, from the configuration perspective, it can be just a few clicks of your mouse. But the migration, the changes on the customer side can be huge. And that's why we will have that order. We will start with basic understanding. We will see which options do I have, and then go into migration. We will not deep dive into migration and see how do I do it step by step. But I will definitely touch on that and give you some ideas on that. So that's the agenda for the next 57 minutes and 30 seconds. Secret Service guys, they will tell you that people usually remember in long conversation the first thing, starting point, and the last point. And they use this trick to make sure that you remember what they want you to remember. So I try to use the same trick with you guys. Let's see how it works. I want you to remember 3 things. And that's basically the summary. Hardware. If you want to be PQC safe, you need new hardware. There's no way around. So in our case, it's Cisco 8000 series secure routers. We call it simply G2, generation 2. And it's also, it's quite fancy game because our boss, G2 Patel, and then G2 routers. So that's a short version of secure routers. This is how I call it. And you need this by 2030, and we will see why. And 2030 is, well, I have time. Nikolai, why now? Well, if I look at the customers, and we have one big customer with 28,000 routers across multiple countries, continents. You need to be 2030 ready. So you need at least 2 years to just, upgrade the router installed base. And then maybe you need 1 additional year for budget and preparation, strategy. And then all of a sudden, you need to start tomorrow. So that's number 1. Number 2 is the control plane. And we will go deep and see what control plane means. But in this case, it's all about IPsec control plane. So you need to make sure that your control plane is PQC safe, including management. We will see how. And the last thing is the data plane is PQC ready, but only if the control plane becomes PQC safe. That's point number 3. So back to my secret service trick. This is my starting slide. And I will end our session exactly with the same slide. So next time you see it, you know the session is over. My name is NikolaiPitaev. I'm Principal Technical Marketing Engineer leading SD-WAN as such. And in my free time, I'm a hockey dad. We have 2 goalies in the family. And man, I wish game 1, yesterday's Stanley Cup final, would take place here. I think 2 years, maybe 3 years ago, we had exactly the situation. So I was speaking, and then the same evening we had Stanley Cup in Vegas. That was great. One housekeeping slide. This is the WebEx space. So please join. We are quite a big crowd. And yes, I can take and I will stop and ask for questions. But please, please use WebEx. Please join WebEx space and ask questions there. Why? I'm not multitasking capable. I cannot answer your questions live. But I have the best Q&A manager, the best guy I can have on the globe for that. And that's Amjad. He's a distinguished engineer working on standards. So let's say you have something which goes deep. We can look into the code and provide you an answer right away. So that's why please, please join the WebEx, and it will save our time. I have a lot of slides. I have some reference slides, which I will not really cover deep. But the best way to keep also in touch after the session with us is by using WebEx. So please join and start asking right away. We do have Q&A managers, and they will help you with the answers right away. With that, let's start. And just very brief, I think we all know that, but just to make sure we are speaking the same language, just a few definitions. So, well, quantum computers are based on quantum mechanics. They are not faster per se as in just a normal GPU, CPU-based architecture. They are not. But in specific areas, they are really fast. And unfortunately for us, or maybe fortunately, we use all the benefits and strengths from quantum computers in math areas, which are used in IPsec, in cryptography. And that's why the second point is cryptographically relevant quantum computers can break the public key encryption systems and the foundation of our digital communication. That's the main point. Why it's not happening now, why it's not available? Well, scaling is one issue. Engineering of such quantum computers is a challenging task. Cooling, error correction overhead. It's not easy. It's a complex stuff. And that's why I say that the quantum computing has a scale problem. The point is, we at Cisco, we're working, and we have a lab in LA area looking at quantum networking. And that can change the game totally, and it will. Because let's say you have low-scale, single quantum computers which cannot break encryption today. But what if you will use quantum networking, and we do have chips for quantum switches and have a link for you. What if you will build a cluster like we do right now with Raspberry Pi's cluster capable of doing a lot of big stuff? What if we will create a cluster of small quantum computers using quantum networking? That will basically bring the skew day, maybe 1, maybe 2, maybe several years, to us. So that's why quantum networking is a really important topic. And also, it's really fun to learn how it works, because they use terms like quantum teleportation. And I wish I can do a demo for you. That will be really awesome. And this is my session number 3. And unfortunately, that's the only session without any live demos. But, well, I cannot do a demo right now. But this is what Einstein called spooky action at a distance. So how many of you are familiar with quantum teleportation? OK, so maybe 15%, 20%. Just a quick summary. So what if I have special coins? One coin will go to Alice, California. Second coin will go to Bob in Frankfurt, Germany. They're magic coins. And the point is, They are connected in a way that before anyone look, no one can say, is it heads or tail, right? But if Alice will look at her coin and if she will see heads, exactly at the same time, Bob coins will be tailed. So they're connected. Even if one guy is in Frankfurt, Germany, and second guy is in San Francisco, California. The main point is it's not magic. We still have speed of light as the boundary. Bob cannot control the result. But if they will later compare nodes, they will see a clear link. And this is what we use for quantum networking, high level. And it's nothing new. Einstein saw it like 100 years ago. Now we're at the stage where we can build this stuff. And this is what we call entanglement. You need entanglement devices. It's science for itself. Quantum networking is really important. It's not for today. I will be not going deep into that. We have extra sessions for that. But back to my point, that can accelerate, that can solve that quantum scale problem by going horizontally and building cluster. And we have it actually in the lab. And then also one point, sometimes confusing people, is what is the difference between quantum resistant on one side and quantum safety on the other hand? I mean, quantum resistant is just keep what I have and try to make sure that what I have is resistant against an attack. And quantum safe is a holistic approach. How do I do it, including software and hardware? And very important link here on the bottom is there's a draft, Post Quantum Cryptography for Engineers. I think it came 2025, and it's just fun to read because what you see is bringing all together and explaining the language and making sure we're all talking the same language, right? So I was saying that quantum computers are really good at math for use for cryptography, and this is 2 points where they are really good and dangerous. Number one is Shor's algorithm, and you see RSA going with quantum computers, depending on the qubits, to 1 day. Diffie-Hellman, 1 day. So that's a huge game changer, and that's why I'm here. That's why you are here. And number two is Grover's algorithm. That's about brute forcing attacks on the symmetric side. So now all of a sudden we have 256 key size shrinking, being equivalent to 128. It's not end of the world, but it's massive reduction, right? You're going from 256 all of a sudden to 128. What is crypto safe, what is not? So we have asymmetric cryptography on top and symmetric on the bottom. I think you all know the difference. I will not go into details. The main message is, if you look at asymmetric cryptography, then large and reliable quantum computers or cluster of small quantum computers can break it. It's just a question of time. And we can discuss we can try to predict, but it's just, we're talking about the time, not if. If you go to symmetric encryption, then it's a different story. So we are safe here, and we will go into details, and we'll try to understand what exactly is going on the asymmetric side and what can be done against that. But that's high level, the message. How many of you are familiar with harvest now, decrypt later attacks? Yeah, so around about 80%. Very easy. I will just briefly touch on that. So let's say you have right now an existing WAN circuit, and you're doing your public key exchange, and it's IPsec. You think you are good. What will happen is someone in the middle can just store your data. It will need a lot of storage. But then, once he has that green box, which is a quantum computer, then maybe in 2 years, it can break it. Depending on the use case, it makes maybe no sense. So we had a project with Olympic Games, right? So they will create a huge setup just for Olympic Games, and then they will tear it down. Not a big deal. Who cares about Olympic data 2 years later? No one. What if we're talking about financial transactions, credit card numbers, social security numbers, medical information? Totally different game, because that stuff doesn't change dynamically. So you need to protect against this. And it's not only like you trying to protect this. It's about regulation compliance, and it's across the globe. It's in the States, it's in Europe, it's everywhere. So now we have specifically focused on the WAN. Why WAN is important? Well, it's exposed. It's more exposed to external entities. We see how is now decrypt later attacks happening. So it's reality. And if you're looking at your WAN infrastructure, you have a long upgrade cycle and life cycle as well. Back to my example was 28,000 routers. It takes time. It takes a lot of time. And all the traditional technologies, SD-WAN, VPN, SASE, they depend on strong crypto. So that's why WAN, that's why you are here. So we have 3 different areas. If you look at post-quantum security, number 1 is what we call quantum-resistant encryption. Here we're talking about key exchange. Here we're talking about key exchange and establishment. And we will look into this in details. Second topic is quantum-resistant authentication. Here it's about certificates, signatures. Must be quantum safe as well. And last but not least, we call it quantum-resistant secure boot. So here is the question, well, Nikolai, I have a hardware which will be booting a software image. How do I make sure that that image is legit Cisco image running on legit Cisco hardware? And you will see how we do it as well. So that's kind of 3 key areas I want you to understand. That's like a big picture, and then we will start diving into details. So any questions so far on the high level?
So, I mean, I would imagine most people here for your big systems, stuff like that, like IBM's Quantum System 2, stuff like that. But, I mean, obviously those types of systems aren't going to be readily available for anybody other than nation states, really big investments and stuff like that. But at what point do you think the smaller individuals, hacking groups, people that just want to get information, at what point do you think they'll have the ability to have questions big enough themselves to start?
Yeah.
Is 2030 still the date that they're expecting that, or?
I got it. So the question is, okay, I got it, Nikolai, with huge giant supercomputers, guys like IBM, they will be able to do it sooner. And the question was, if you look at smaller groups, like hacker groups, et cetera, what is the time frame they be able to break it, right? That's the question. Okay. So, well, let me give you an example with Mythos. So we are one of 11 companies which got Mythos up front. We used that. We improved security dramatically. I think same day as we got Mythos, it was a leak, and Mythos was leaked to some hackers or other guys. So I think the same, you cannot say it will be a much longer period of time till these guys will get it. Because what they can do is, yes, they don't have supercomputers. But back to my point was quantum networking. Yes, they will do a cluster, and they will try to break using smaller computers in one cluster. And this is something, I mean, they will do, because they can just buy a quantum switch later on from Cisco and do it in the same day So there's no big time shift, I would say. But again, that's just me, Nikolai, it's just my speculation. Yeah, so the question was the 8,000 secure routers, are they quantum resistant? Short answer is yes, we will have it on the slide. Okay, in interest of time, I will move and redirect additional questions to the WebEx, otherwise we will be not able to go through all this stuff. Okay, but yes, you will see it. So now control plane. What does it mean, control plane? For me, as a networking guy, CCIE control plane is like BGP, maybe, and if you look at SD-WAN, it's OMP, so it's a routing protocol using Dijkstra algorithm just to find the best, shortest path. Okay, OSPF, good. Is it quantum safe? Maybe someone will understand on the control plane something different. So the short answer is the traditional control plane definition as long as safe, as long as IPsec is quantum safe, because it relies on IPsec. So in the next slides, we will focus on IPsec. And then you will see the implications to SSH, to different protocols as well. If it's IPsec, then we have 4 different areas. We have key exchange, we have authentication, SA, and key derivation. That's where we'll be looking at. And the question is, OK, I got it, control plane, mainly to IPsec. So tell me, what about individual points 1 to 4? Is it a quantum safe or not? Question?
You were asking a question, right?
Oh, no, I thought you had a question.
No, sorry.
OK. Yeah, so that will be the next point, saying, OK, we have key exchange, which is Diffie-Hellman, and that will be broken. So the PQC replacement is MLCAM, and then FIPS 203. Now, basically, a lot of people will say, well, Nikolai, full stop. What is MLCAM? What is FIPS 203? I have no idea. Explain it to me. We will come to it. So that's just an overview, and you will see algorithm, MLCAM, standard 203. So for newcomer, a lot of new definitions, but actually it's just another language. But if you understand, OK, Diffie-Hellman can be broken, MLCAM is the algorithm, and you will see the comparison. Standard, life is good. Second point, now, number 2 was authentication. RSA, same idea, algorithm, standard, MLDSA 204. And this is where we use that, like certificates, IKV2 authentication, et cetera, right? SA, it comes back to key exchange, which is again MLCAM, and authentication. And key derivation itself, it's safe. And here the main idea is, well, the weak point is here the key itself. So what if I will try to mix the key? And you will see simple idea, let me use my standard key exchange and let me add PQC safe key exchange as second step and just mix that. That's the whole point. So it looks strange for a newcomer, a lot of new RFCs, a lot of different new terms, but the ideas behind are really simple. And my goal is actually not to bombard you with the RFC numbers, but my goal is to explain in plain English what does RFC 8784 mean. Okay? That's the key slide for the understanding of the control plane. We have 2 different options. Option number 1, this is what you see here. We call it Post Quantum Pre-Shared Key, PPK. So what we do is we will see how we can make pre-shared key quantum resistant, right? Second is post-quantum cryptography. Totally different approach. In this case, we will replace all algorithms with the new one, providing similar functionality. It will be not like always feature parity. Feature parity is a dangerous word because sometimes it will not give exactly the same functionality. It will give similar functionality, but quantum safe. So that's exactly the mini agenda for the next slides. I will start with PPK, Post Quantum Pre-shared keys, and then transition to Post Quantum Cryptography. So option one, again, what I'm doing is I'm looking at pre-shared keys. If you look at traditional IQv2 key derivation, right? You all know this. We have Diffie-Hellman, shared secrets. We have KDF, key derivation function. And then I'm getting the session key, which is not quantum safe. So, OK, what do we do? Well, the idea in plain English is simple. Let's add second key. That's the blue key post-quantum pre-shared key. And that will make, all of a sudden, the whole stuff quantum resistant. So we have two sides, right? Responder and initiator. If both sides have that PPK configured and available, they will use it. Then I'm using PPK-based IQv2. I'm good. For the migration duration, what if one side does not have it? Then I can say, I want a fallback to a normal IQv2. So this option, that second table, will allow you to fall back to the old way. And let's say later on you are done with migration, you can disable that fallback option, and then we will abort the session if one of the sides will not support that. So just keep it in mind. This is how would you use it for the migration purpose. Main point is you must have the same PPK on both sides. So how do you do it? Well, you can configure it manually. Does it scale? Probably not. So what do you do? Second option is you can import the key from external source. And that's the protocol skip, what you will see in the next slide. So if you don't want, or if you cannot, because of scale, because of operational handling issues, if you cannot do it manually, well, skip. This is exactly what it is. It will require dedicated optical fiber. This is what I highlighted here. So it's second communication channel. It's not inline. It's out of band. That's why it's also secure. So what you have here is you have the second quantum channel for the key distribution. And using that channel, you make sure that the key will be shared across two sides, and you can use it in a safely way. Is it simple to operate? Well, it's not inline, so it will require some handling, yes. But that's the price you pay if you don't want to do it manually on both sides. That's actually the key exchange, and I don't want to go through all the details, but I want to highlight this out-of-band thing. This is exactly what we see in the call flow for that exchange on the PPK side. You will see a lot of reference slides. That's why I have this icon. So in the interest of time, I will save it. I will sometimes skip this, but I want you to give more technical meat than I can present in 60 minutes for your reference. Depending, you will see a DMVPN configuration examples. It's all for your reference slide. OK, and then one last slide on skip. Very important topic. This QKDA is point-to-point only. So if you have a hub and two branches, you will need to deploy two devices, one for branch 1 and one for branch 2. And then they will exchange both sides. That's why I have animation on the left and on the right. The main point is it's point-to-point only. It's not point to multi-point. That's why for the hub and spoke, you will have two. OK? Reference slide, how you configure that. Typically, I read it from the bottom to the top. So I have my physical interface, gigabit Ethernet 1. Then I have my tunnel interface, which is mapped to this gigabit Ethernet 1. Then I go up. I see my crypto profile, the keyring, and that's pretty much the whole config for the manual PPK. Simple. And the next slide will show you an example of CLI output. You see QR, which is quantum resistant, because we're using, still, remember the difference, quantum resistant. And you see here the quantum safe encryption is using manual PPK. And the same reference slide for the skip configuration, similar approach, very easy config, straightforward. The only difference will be the second line. Now I see dynamic QKD PPK method in use, the last line, which I highlighted in yellow. That's the only difference. Okay? That was question? Say again?
Like after Diffie-Hellman runs, does the quantum now run after that, or do they do it in parallel?
Yeah, so the question was, once I have, it's in the call flow. Let's, after the session, I can go back to that call flow diagram and show you where it is. So option 2 is now we're going to PQC. Now we're replacing algorithms. That's the main difference, right? So we're talking about new stuff. MLCAM, all these new replacement algorithms came from 2017-ish to 24 and then to now. So that's new stuff, new algorithms, new standards coming as a replacement for Diffie-Hellman and RSA, right? That's the second topic. Again, MLCAM is the algorithm itself. FIPS is US standard, right? And once you have algorithm and standard, then it's a bunch of ITF drafts for how to use it in SSH, how to use it in TLS, how to use it everywhere. But if I go back, it all comes down to the same idea. So it's all MLCAM, and let's see what it means, right? In plain English, it's a quantum-resistant way how two parties can agree on a shared secret, which is now actually safe. That's the main idea. And these guys have 3 different functions. One is the key generation, NCAP, and DCAP. And you will see it in action on the next slide. So what we have is we have a comparison. That's the old way, right? Diffie-Hellman, you know all this. They exchange the public keys and then create shared secret. Not safe. Now with MLCAM, it's slightly different. Only one side will send the key over. So see, I'm sending from left to right public key. There's no second public key sent into opposite direction. It's one way. And then I'm doing my NCAP function. I got my shared secret, and I have the ciphertext. It will be sent back, and now I'm using DCAPs to get this shared secret. And obviously, that shared secret on the left is exactly the same as shared secret on the right. That's the main difference. Not a rocket science, very easy to explain, probably hard to implement, but that's why we have Amjad and brilliant developers doing that. But main point I want to highlight is old way is one-to-many. So hub to spoke, you can do it. You can use the same to multiple branches. New stuff, one-to-one. That's the main difference. We have multiple parameter sets. The second one is the default. One point of confusion is the number. 768 or 1024 is not the byte size. And the last one, 1024, is actually above the MTU you would normally have in your network. So that's why if you're using MLCAM 1024, it can create IP fragmentation. And that's why I highlighted that point here. So you should use IQv2 fragmentation in order to avoid any fragmentation issues down the road. Because if you look at this, the parameter set itself, it will say MLChem 1024. You would assume that's the size. It's not. So then all of a sudden you have all the fragmentation issues. So just keep this in mind and deal with that. So now we go from the algorithm to the protocol extensions. Back to the idea, what if I will still use the old way and add the new way on top of it? So I'm just combining two into one final secret. That's the whole idea. And you see it, I think, on this animation. First, I run the classical key exchange, which creates the shared secret 1. Then I run the same thing with Post Quantum exchange, generate shared secret 2. And then I combine both and use it as my main shared secret. That's exactly the idea behind that. Still with me? OK, good. Good. Just checking. So that's, again, more for the reference slide. What is the additional impact if you compare old with new? So what we highlighted here, you see some additional exchange messages. Typically, the question will be here, Nikolai, what is the impact of PQC to throughput? If you took the G2 router, what does it mean for my PQC throughput? Park this question. I have a slide for this. Again, more or less reference slide. How do I configure that? You see here I'm doing PQC MLChem 768 and similar output for show crypto IQv2 SA detailed. Now I'm using that MLChem 768. I'm good. Now moving to authentication. Now I'm talking about FIPS 204. So we're moving to post-quantum digital signature algorithm and the standard. So how do I create the signature? How I do verify the signature? That's the whole task of this guy. Again, algorithm and the standard, same thing. For many people, just new abbreviations, but the idea behind this is very simple, right? There's slightly difference. I try to basically explain difference between 204 and 205. One is practical, fast, and modern. Second is ultra safe as a conservative fallback. That's pretty much how I try to explain high level the difference between 204 and 205. So we spent a lot of time on the control plane. Just to summarize what we had is, we talked about option 1, which is PPK, post-quantum pre-shared keys. We talked about option 2, which is post-quantum cryptography. We saw the 4 topics, and I tried basically to arrange the building blocks just to visualize who is doing what. That's my mini summary for control plane. Now moving to the data plane, and that's easy. So for data plane, I will use just one slide. And as I mentioned in the beginning, encryption is good, integrity is good, key usage, well, it depends. So the real risk is actually the data plane is as long as safe as your key, and it's coming from the control plane. So in a nutshell, IPsec data plane is PQC ready, but only if you've done that control plane right. That's it. Other than that, we're not worried on the data plane. Back to the point of throughput, we're not changing anything, so there's no impact on throughput. The only impact you will see later on, it will be session establishment time. If you are bringing up many, many tunnels, because of additional exchange messages, it will take slightly longer, and I have a slide for that. But that's pretty much the whole data plane story. Now moving to Cisco hardware and software. So I'm not really going into details and fancy and really interesting stuff of universal quantum switching, entanglement devices. I'm not talking about QPU. It will be fun to show you the teleportation demo, etc. Not today, maybe in a few years. What is really today is the second block, which is post-quantum safe routers. So we have now the G2 routers, Cisco 8000 series secure routers, which are secure. And that's the main point for this demonstration. So that's basically the whole portfolio. And the short message is, take G2, you're good. That's it. And then on the software side, next slides, you will see, depending on the software solution you have, it's 26.1, which is already released, or it's 26.2, which will be released in August, September timeframe. That's it. That's the whole message. So again, throughput is a really important thing. No impact on data plane. AS256 remains AS256. We do it for years, so no changes. Control plane, no impact on throughput. It can be longer because of additional messages. So I think the first estimation I got from our test guys, it can take, if you're bringing thousands of tunnels, it will be up to 10% longer compared to the old solution. That's what I have. And why? You see here in the call flow comparison old on the left and new in blue on the right side. And you see additional messages. So you see, let me grab the pointer. We have like a few messages, few additional messages, like 2 to 4 additional messages here, and there. And that's why if you sum up, it will be 8 additional, or can be up to 8 additional messages, and that's why it takes longer. So it's not like a problem from the G2 routers, it's just the way how the new algorithm is implemented with additional messages. Very quick, back to the point, how do I ensure that Cisco router is booting Cisco software? It's not modified. And we have some high-level military customers. If they travel to countries which are not seen as trustworthy, if they come back with the routers, they burn routers. And military guys are military guys. I was trying to explain them, hey, we have tamper detection, we have all this fancy stuff, how to do, even if the box is powered off, if someone will try to open G2 router, you will see a special message in secure chip saying it was opened at that time, it was closed on that time. And then in addition to that, you're getting a syslog message. Military guys just burn the box. So, but again, and this is exactly the point, that's the show output. If you do show platform tamper detection, nothing to do with PQC, but that's one part of the puzzle, making sure that we take it seriously, and you will know if someone tried to open the box, it was modified or not. That's the first step. And then on top of it, back to the digital signatures. Before booting, the G2 box will check that that software image on the flash is actually signed by Cisco in the PQC safe way. That's the main point, hardware booting up the right software. And the hardware is not modified. So moving to solutions, and we have many. You see here IQ to IPsec, DMVPN, FlexVPN, all the way down to SSH. So it's all available on 26.1, which we released recently. So all this software stack is PQC safe. So G2 plus all this is available now. Why? At the end, it comes down to MLChem. So once you implement, once you got MLChem right, then with all the protocol extensions, you're getting all the solutions almost immediately. And then I have one reference slide for each solution, like DMVPN, FlexVPN, MACsec. That's the reference slide. I will not go into details because it's maybe specific for some customers, not for other guys. So I will just flip the slides, but you will have it for offline reading. That was my goal. So that's the slide describing the MVPN. The next one is FlexVPN. Then we have cluster load balancing. We have MACSAC. We have certificate-based encryption. And the management plane was SSH. So that was really quick, but that was done on purpose because you have the slides, that's for your offline reading. Now going to SD-WAN, and SD-WAN has a lot of built-in security features. But yes, we have integrity on the hardware side. Yes, we have zero trust mentality. We have all this built into control and data plane. But if it comes down to PQC, then the simple answer is 26.2 software. All what you need to know is it's like maybe 3 clicks, maybe 4 clicks on the UI, or maybe 1 or 2 API calls, depending on your operating model. What we have is we have control plane using standard-based TLS in 26.2. DTLS is on the roadmap. It's not in 26.2, it's coming next. Data plane, that's the communication between 2 blue routers using standard-based IPv2 IPsec, and it will be available in 26.2. I still have that disclaimer subject to change roadmap because on Cisco Live stage, they don't want us to present you, to sell you future. But we know it will come. We know it's already in the code. And we know that 26.2 is coming in August, September timeframe. So that's why I still have that star as a footnote. But we know it will come. So this is something where I feel comfortable sharing with you guys future. So I'm not selling something which is far away. I know it's coming. And last but not least, on the server side, on the LAN side, we have CLI add-on profile you can add. And you can also run PQC safe communication on the server side, on the LAN side as well. So we got you covered on the control plane, data plane, and the server side. And back to my point was a few clicks. So if you're familiar with configuration groups, we have here new fabric security profile, which you will then be able to select. And then all what you need to do is you go to PQC, you're using MLCam, you're done. You push it down to the routers. So the configuration is easy. Migration is a challenge. So we had some discussions saying, Nikolai, great, but explain me how do I migrate a branch? Because there's a one-way street. So, OK, I have my old router, which is not G2. You want me to install G2 router next to it, and then in the maintenance window, right? Because it's an interruption. Is it? Well, do I have a migration guide? Stay tuned. That's exactly the point on that migration side. Because I think for you as a user, you will be not going deep into MLCam, call flow, et cetera. For you, it's just a few clicks. But the implication on the migrations and how you do it in your environment, that's a challenge. And I acknowledge that. And it's my job to make that also as easy as possible for you. And that's why we come up with a migration guide, not for SD-WAN, for DMVPN. But we have published that. We will do the same for SD-WAN, because once we release it, we will also work on migration guide. So, I mean, Master Yoda will say do or not do. There's no try. In this case, there's no not do. It's like you have to do it, period. US, Europe, 2030, that's a time frame. So it's just a question of how I do it. High-level slide, I will start with education. That's what we're doing now. Second step for me would be I will assess and define priorities. Then I will research my options. What do I do? PPK, something else. How do I do it? Manual, whatever you want. And then I will create a strategy. I will execute the strategy, monitor the progress, And that's basically, sorry, I was too fast. And basically that's a high-level, obvious way forward. Nothing special, not a rocket science. You would do it for any migration. So what's the difference to PQC? Well, what you see here on the left side is a guy who is not PQC ready. That's the yellow box. In the middle, we have G2 routers. And here on my right side, we have PQC ready peer. So this is secure tunnel, easy. I have MLCAM all in place. Life is good. On the left side, I'm running non-safe yellow communication for my migration phase. So this guy in the middle can do both, right? He can speak old to the left. He can speak new to the right. Still easy, but now we're coming to hub and spoke migration. How do you do it? Well, IPsec VPN migration is easy. You have initial state, which is all yellow. Then you upgrade your hub router. You do it spoke by spoke. And at the end, you upgrade it both. Now your PQC encryption is complete. You are done. That's just a standard IKv2 IPsec VPN migration. The challenge would be on the SD-WAN side. So the question was from one of the customers, well, I have my hub and spoke. What do I do with SD-WAN? So, well, similar as a normal migration, you will create a new hub. So this guy is the G2 router on the hub location, creating control channel to SD-WAN manager. So in the old way, that will be vManage. We call it now SD-WAN manager. And obviously, two SD-WAN controllers as well. Then I'm doing interconnect. I'm migrating the branch from old to new. And then I'm running the quantum safe communication. And again, this is something we need to spell out for you. It's not released capability yet. It's coming. Once we will have the code shipping, we will also come up with a migration plan. What I would like to highlight, I think that's the next slide. We have press announcements, so we have also partners. You will see AT&T business announcement in May, beginning of May, maybe a few weeks ago. We had the same from Orange in Europe. So this is something what is coming, and we have partners helping you and helping us on that front. And that's exactly the migration guide which we published. So that's a quantum-ready migration guide available on CCO, published, I think, in the beginning of May. And that is focusing on the DMVPN. You can download this now, and we will have similar white paper migration guide for SD-WAN as well, because we know this is something you guys need. OK, so with that, let me come to the last point, summary. It's a big slide serving one purpose, saying Cisco is driving quantum internet, quantum chip development, IETF drafts, the whole PQC stuff from 2013. So in-house, we have brilliant engineering guys which can do full stack, starting from quantum networking all the way to MLCAM standard implementation and IETF work. Try to find another company who is doing exactly this. I will not go through the details and touch on specific points, but I think you got the point. This is exactly what I was trying to do. Remember three areas. Remember quantum-resistant encryption, that Q-safe key exchange and establishment. Why? Because that will protect you now against harvest now, decrypt later attacks happening now. So this is something which is urgent. This is what you need to look at, the first bucket. And then you're moving to quantum-resistant authentication, certificated signatures. And the last bucket is addressed with actually secure boot and G2 hardware. That's pretty much, in a nutshell, the summary of three different areas. And again, the big picture is very simple. So we are really pioneering quantum development, quantum internet from day one on software and hardware front, including standards. This is something also we have stolen from a different session from one of our fellows. It's a great illustration saying, on the left side, you have quantum apps for quantum networking. That's the left side. And here you have all the fancy stuff with entanglement protocols, with PQC, NIC, etc. On the right side, you have basically quantum for traditional, for classical networking. And we have demos, we have different activities and use cases in all places. So that's exactly the big picture. And it's also clear that quantum computers will break secure algorithm, depending on the question before, big guys first, and maybe next day, smaller guys later. But it will happen. And your WAN must be quantum safe by 2030. Sounds like you have time. Depending on your size, depending on your speed, upgrading 25,000 routers in 2 years, is it realistic? It's a challenging task, especially depending on your use case and maintenance windows. So that's why, and then, budget, certification, all the stuff will bring you to tomorrow. So still remember the secret service trick? So 3 things to remember. And that's the last slide for today. So number 1 is you need quantum-ready hardware. In Cisco case is Cisco Secure 8000 routers, which are available now. And you need to have them in the WAN by 2030. Depending on your use case, critical infrastructure sooner, maybe you will get a few years later if you are not critical, but it's your decision. Still, unsure, well, will we have 2030 or maybe 2028 was the Q day. Number 2 is remember that control plane, we have 2 options, PPK and PQC, we talked about that. And it comes down from routing control plane to IPsec control plane. You need to harden management, you saw SSH, using MLCAM, you are good there. We removed Telnet, we removed unsecure protocols. The system will be smart enough to say, hey, Nikolai, you're still using somewhere HTTP. You need to, disable all those unsafe services. This is something which is built in the system, and the system will tell you if you're still using that. And data plane is safe as long as your control plane is safe, and there's no impact on the throughput. Remember that 10% longer time on session establishment and no impact on the throughput. So this is exactly what I wanted to cover. We have 25 seconds left, so I will close the session, but we will stay here, come and see us in case of any questions. Thank you so much.